Biggest thing with 2.2 deals with quadratic functions and the different types of graphs of quadratic functions. This is one thing actually I'm working on we're going through the quadratic part in my Algebra 2 classes right now, or my Advanced Algebra 2 classes. So this is kind of a little bit of the same. The biggest thing you have basically two forms, and already this is not correct as far as the standard form of a parabola. This is not the standard form, or in my interpretation, this is not the standard form. This is what I call the vertex form, where it's the f of x equals a times x minus h, quantity squared, plus k, where a can't be 0. If a is 0, then you're dealing with a constant. So this is actually vertex form. Standard form is, or at least what I call standard form, and what I've always seen standard form is f of x equals ax squared plus bx plus c. They may call it general form, but if that's what vertex form, because we can always find the vertex with this one here, and then standard form is when it's in that ax squared plus bx plus c. So either way you can graph it with anything. So whenever you have vertex form, or what the book is calling standard form, basically remember that whenever a is your scale factor, so a is your scale factor. A couple things to remember, and you already had a lot of this whenever we talked about the transformations and stuff like that. If it's positive, it goes up. If it's negative, your graph goes down. If a is greater than 1, then it's going to be a vertical stretch. If a is between 0 and 1, so it's a fraction between 0 and 1, it's a vertical shrink. Then whenever you deal with, if it is minus h or plus h, oops, wrong one. Remember, minus h, it's going to go right. If it's plus h, it's going to go left. And then with the k, if it is minus k, your vertex is going to go down. If it's plus k, it's going to go up. So I guess really I should, in terms of positive, like here it's more flipped over x-axis, so then you don't get those confused. If it's positive, it's going to look like that. If it's negative, it's going to look like this. That's a lot of the same stuff that you've already dealt with in terms of finding the vertex. Plus 8. Okay, so first off, I want to find my vertex. So of my vertex, what am I going to do with the minus 3? Which way am I going to go? which way is that one going to send me? I'm going to send it right 3. Okay? So I'm going to go right 3, and then I'm going to go up 8. So then my vertex is just at positive 3, positive 8. So then over to 3, up to 8, put my point. So now if I'm doing this by hand, I want to go, I always move from my vertex. I'm going to slide one spot to the right. Where's my next step? I'm going to look here. Where am I going to go? How many am I going to go? One right. How many am I going to go up or down? Down 2. And then match that point. Now, normally I would go from that point, I would go one step over, and I would go normally up 3. But what am I going to do with that 3 now? Multiply it by negative 2. What's 3 times negative 2? 6. So I'm going to slide, I'm basically going to slide one step over and then 6. So my next step is right there. Same way, if I would draw like these lines, okay, how many steps down is going to be my next one? I'm going to slide one to the right. How many down would I go from there? Normally I would go up 5, but since I'm multiplying that number by negative 2, I would go down 10, so it's going to be somewhere all the way down here, and my next point, oh, I'm short one, my fault. So then my actual parabola is going to look something like that. Now, the red lines are really just so you can kind of get how the steps are going. Everything is always going to be one step to the right, one step to the left, and then kind of going from there. On 2, I have x plus 3 quantity squared plus 1. So where's my vertex going to be at? Negative 3, 1. So negative 3, positive 1. Now, does anything change? Do I have a number in front of my x plus 3 squared? No. So then I'm going to slide one step to the right, 1 up. From there, I'm going to slide one step to the right and 3 up. Then I'm going to go one step to the right and up 5. And then I'm out of room. Basically, what I want to do from here is match everything on that side of that imaginary line that I have here. 1 here and here. And there's my parabola. Big thing you need to know, domain of any quadratic is always going to be negative infinity to positive infinity. Okay? Your range is all dependent on which way it goes, whether it goes up or down. And whenever we talk tomorrow about like the minimum and the maximum, that will play a role in what your range is. But it will always be your y value of your vertex. Okay, so they call in function form, okay, or where it's the form of, this is what I call standard form, where it's ax squared plus bx plus c. Okay, so if it's not in vertex form, but this is what I call standard form, easiest thing to do is find what's called the axis of symmetry. That's just going to be your x value. Okay, of your vertex, where you find the opposite of b divided by 2a. So whenever I do, you treat it just like you would quadratic formula. Okay, So with quadratic formula, I have A, I have B, and I have C. So A is -1 because it's the value that's in front of x squared. B is 4, and C is 1. Now I'll give you a little hint. If you don't know this hint, this value that's on the back end, whatever your C value is, that is your y-intercept. Okay? Whatever you have, if it is in standard form, or what I call standard form, where it's ax squared plus bx plus c, whatever you have back here, whatever your constant is, that is your y-intercept. So you automatically have a value that you can put on your graph before you even know where everything else is. Okay? So you know right now, starting out, that I'm going to have a point at 0, 1. So right here. Okay? I am automatically going to have a point right here on my y-axis of whatever my constant is. Okay? So from there, then I need to find basically my vertex and my axis of symmetry. So basically that imaginary line that's going to run through. The axis of symmetry, remember, is just your x value, which is the opposite of b over 2a. So what's the opposite of 4? -4. Divided by 2 times -1. So 2 times -1, so I have -4 over -2, which is going to be a positive 2. So my vertex is going to be at 2. So what I like to do, and especially if I do this by hand, is that I'm going to have basically an imaginary line through x equal to 2. My vertex is going to be somewhere on this line. Now, I also have another point that I can graph because I have y equals 1. Where's my other point going to be? Other way around. So 4, 1, right? Okay, because it's going to mirror, remember, the parabola just mirrors itself. So wherever that imaginary line is, I'm going to have another point that now I have 2 points. I still don't know where my vertex is. I just know that it's on this dashed green line somewhere. So what I've got to do is I've got to take this 2 that I have, and I need to plug it back in. Okay, I need to find the second part. So I'm going to take this 2 that I got right here, and I'm going to plug it back into my whole function. So I'm going to have -2 squared. Now, it's not -2 squared, but it's negative and then 2 squared plus 4 times 2 plus 1. Plug and chug, I have -4 plus 8 plus 1. So my y value of my vertex is at positive 5. So that 5 just goes in here for my vertex. So I'm going to go up here to 5. And then connect the dots. Now it says identify the domain and range. What have we already said, or what did I already say earlier? What is your domain every single time? Negative infinity to positive infinity. If you don't get that right, okay, somebody's going to smack you upside the back of your head. Not really, but I'll have you do it to yourself. Now, what's your range? Where's your y values going from? Where's your lowest value? Where's your highest value? Negative infinity to 5, making sure that 5 is included. Okay? Whatever this value is, right here, it will go with your range somehow, some way, every single time. Okay. I'm actually making my Algebra 2 kids find the x-intercept and the y-intercept as well. We already kind of did the y-intercept, but I'm making them find everything. I won't make you find everything.